All right, guys, so before we get started, are there any questions over the homework? Any questions over the homework assignments? Questions over the homework? So you'll need the other note sheet.
Okay, I got the other thing.
Yeah.
Yeah, you're a goofball.
All right, guys, if there's no questions over the homework. Yes. Number 19? Thank you. Yeah. All right, guys, so we're going to look at problem number 19 from 1.3. So 19, guys, is a horizontal shrink by a factor of 1/2. Since it is talking about horizontal stretch and shrink, we're using our g of x equals a f of ax. Now, since the value of a that they gave us in the problem was 1/2, we have to flip it from 1/2 to 2, which tells us that g of x is equal to f of 2x. Now, at this point here, we don't have f of x anymore. We have f of 2x. So every x in the equation has to be switched from x to 2x. So we'll still have the absolute value bar. We still have the 2, but instead of x, we now have 2x. So inside the absolute value bars, we now have 2 times 2x, and we have the plus 4. Now at this point here, we just need to simplify. So our 2 times 2x is going to be 4x, and we have plus 4 still.
I need Juliana Dietrich to come to the office. Juliana Dietrich. Thank you.
Any other questions on this here? All right. All right. What we're looking at today is systems of linear, or systems of equations, systems of linear equations in 3 variables. Now, y'all have done systems of equations before. It's just been a while. As in Algebra 1, you did systems of equations, but the main difference is instead of using 3 variables, you had 2. We're looking at equations of lines. And with 3 variables, we'll have x, y, and z. Is an equation of this here where a, b, and c are not all 0, because if they're all 0, we don't have an equation. We have to have at least one of the variables be not 0. Now, this here is an example of a 3-variable system of equation. We have 3 equations with 3 variables. A system is an ordered triplet. So a solution of the system is going to be an ordered triplet. 3 points, or 3 numbers that make a point. And what these numbers will be, x, y, and z, we'll find 3 values that will make all 3 equations true. It has to be true for all 3 equations, because if it's only true for 1 or 2, it will not work, because it has to be true for all 3. Now, there's different ways that we can have a solution, or not. One of the first one is this one here. Now, the ones on your page are a little bit smaller. I made them a bit bigger so that we could see them. So this one here is exactly one solution, where all 3 planes, because an x, y, z equation, linear equation, is going to be a plane, like a sheet of paper. Then we have exactly one solution. It's going to be the one point where all 3 of the planes, all 3 of these equations intersect. It'll be included in all 3. This one we have one solution. Now the next type of solution we can have is infinitely many. And it'll look like this here, where all 3 planes intersect at a line, or it could be a plane. We can have a line or a plane, but they all 3 intersect at one spot. Now, for the most part for this here, we'll call this all real solutions, but there is a way to define what those solutions are. We can actually find an equation, and one of them could be a plus 2, 2a minus 1, well, put a parenthesis way too soon, comma a, like this here. And really, any value of a that we plug in for in the z's location and plug it into the other two will give us a solution. And the number of values of a that we can have for this is, well, infinite. So it is infinitely many. We just have a way to define what those solutions are of that infinitely many solutions. Because with systems, it's not that every solution will work, only a certain number, but that certain number is infinite. Then we also have no solution. And we have these three types. One, all three planes are parallel to each other. They don't intersect at all. Now the other two, we do have intersections, but we don't have one where all three intersect, because it has to be true for all three equations. Because for the middle one, yes, these two lines here, two of the equations, it does have solutions for those points, but it's not true for all three. It has to be true for all three for it to work. And we'll look at examples of all these here. Not so much these specific ones, but ones that are one solution, infinitely many, and no solution. Any questions on any of this here so far? Now, I did include this in the note sheets. You do have this. Rewrite the linear system in 3 variables as a linear system in 2 variables by substitution or elimination. Solve the new linear system for both its variables, substitute, and then go back. Okay. So we do have all this here. One of the main points, if we ever get an equation that 0 equals 1, where all the variables simplify out and we get a statement like this here, it is no solution. Mainly because there's no way that 0 is equal to 1. Or if we get a false statement, it doesn't have to just be 0 equals 1. It could be 2 equals 3. Normally it will be 0 equals 1 or 0 equals a number, but if we get a false statement, it's no solution. If we obtain a true solution, 0 equals 0, 2 equals 2, where it is true on both sides, it is our infinitely many solutions. Now, we're going to do these here mainly by elimination. We're going to solve these by elimination. So the first step in solving these equations by elimination is to first pick an eliminator equation and in a variable we want to eliminate. So the first step we can say pick a variable to eliminate and an eliminator equation. So what that means is when we look at this here, x, y, and z, we need to determine if we want to eliminate x, y, or z first. We need to pick one variable to eliminate. And normally when I pick a variable to eliminate, I pick one that I can turn it into the other two easily. So if we look at x first, we have 2, 4, and 6. Always look at the smaller value as the one to use. So we have 2 is the smallest, yes? Can we easily turn 2 into 4 or 2 into 6? Yeah, because I can take 2 and multiply it by 2 to get 4. I can take 2 and multiply it by 3 to get 6. So we could eliminate x. We can use x. Y, let's look at its value. So we had 1, 2, and 3, yes? Smallest value is 1. Is it pretty easy to turn 1 into 2 or 1 into 3? Yeah, because 1 times 2 is 2, 1 times 3 is 3. Okay, x and y work good, work well. It doesn't matter, because we're going to pick one of them. Now z, the smallest value is 3. can we easily turn 3 into 4? No, we can, because I can multiply 3 by 4, but I also have to multiply 4 by 3. And the same thing's true with 5. So it is possible to use z, but it's not going to be the most efficient. So really x or y. So which one do we want to eliminate first? X. Okay. So the first thing we do is, one, pick a variable to eliminate out first. Because what we're going to do to solve this is go from 3 equations with 3 variables to 2 equations with 2 to 1 equation with 1. We're working down, and then we're going to work backwards. So we pick that. Now, that's part of the first step, was pick a variable to eliminate, and then it said an eliminator equation. That part might be a little bit confusing. But all we're doing, because again, we're going from 3 equations with 3 variables. Once we do this, we'll have 2 equations with 2. Now we need an equation to actually cancel that one out. And I'm always going to pick the one that has that smallest variable. If there's more than one with it, it's dealer's choice on which one we use. We're going to pick one of them. So we're using this here. And what we're going to do is multiply it by whatever we need, so the values in front of x, the one we're eliminating, are the same. So we're not going to have to do anything to our 4x plus 2y plus 3z equals 12, or the 6x minus y plus 4z equals negative 3. Because those 2 equations we're going to be removing x from. And we're going to be using the one I highlighted, our eliminator equation, to eliminate x from them. Questions on this so far? Now the next step I'm going to do is I'm going to do it out to the side. This is scratch work, so I would not put it below either one of these. Is that we actually need to get the x's to be the same. So if we look at the one on the left, the value of x is, or the value in front of x is 4. So we need this 2x to be 4x. And to get it to be that, we need to multiply it by 2. So we're going to scale, as we call using a scalar, is I'm going to multiply our 2x minus 3y plus 5z, both sides, by 2. 2x minus 3y plus 5z and negative 7. So again, when y'all are working on these, I would always do these off to the side. This is scratch work. Now we multiply by 2. 2 times 2x is 4x, which is exactly what we wanted. 2 times negative 3y is negative 6y. 2 times 5z is plus 10z is equal to negative 14. Any questions on how we got this equation here? We good with what we've done so far? Questions? Because once we get this, we're going to put it right underneath. Here, 7. Yeah, so we're taking it straight from the equation, so it'd be negative 7. Yeah, I had squished it in a little bit. Bless you. Okay. Erase that line there. Yes. Yes. So we are good with how we got the first equation, yes? So we're going to end up doing the same thing for the other side, but before we get there, we do want to eliminate the x. Now the question becomes, do we add or subtract? Because we want the x values to become what? 0. We want them to cancel out. Because 4 minus 4 would be 0. 4 plus 4 is 8. So here we will subtract all the way across. One way to try to remember that is either, well, there's 2. One is actually try both addition and subtraction with that. So we can do 4 minus 4. Okay, that is indeed 0, so we're going to subtract. 4 plus 4 gave us 8, so we're not going to add. But the other way is if the signs are the same, they're both positive or both negative, we subtract. If they're opposite, we add. Because a positive added to a negative of the same value will be 0. 4 plus negative 4 is 0. Or we can just do both and see which one actually gives us 0. We wouldn't in the calculator. If you plug it in, don't plug in the variable, just plug in the number itself with its sign, and we will get what we want. 4x minus 4x is indeed 0. It was eliminated out. It canceled out just like we wanted. Now we need to finish going through the rest of it. 2y minus negative 6y. Well, a negative and a negative makes a plus, so we get 8y. 3z minus 10z is 10 minus 3. Yep. So 3 minus 10 is negative 7z equals 12 minus negative 14. Well, the negative and negative do make a plus, which is 26. So I've taken two of the equations, used elimination. Now I have one of my equations with two variables. Okay, now we're going to repeat the process to the other side. So we want to eliminate 6x. So what do I need to multiply our eliminator equation by to get 6x? 3. So we're going to multiply both sides of 2x minus 3y plus 5z by 3 and our negative 7 by 3. So if I distribute the 3 through, 3 times 2x is 6x. Bless you. 3 times negative 3y is negative 9y. 3 times 5z is plus 15z. And negative 7 times 3 is negative 21. Bless you. Now when we're doing this step, I'm not so much focused on the signs being the same. You can do that if you want. But I'm focused more on the number, because I'm making sure that the x's both have 6 on the left-hand side, or on the right-hand side, that both of the x's have 4. They are the same. Any questions on this here before we move on to the next step? So will we add or subtract? Subtract, because 6x minus 6x, 6 minus 6 is indeed 0. Now again, I go on and draw the subtraction sign between each of our terms. One is a way to remind myself that we are subtracting all the way through, because again, if you're not used to doing this, it's very easy, very tempting to switch from subtraction to addition partway through, especially if we have a case like this here where the negative became plus and we switched over. So I draw it all the way through. But also, I'll show you here in a second, because 6x minus 6x, 6 minus 6 is indeed 0. They do cancel out. The next one, negative y minus negative 9. Well, our subtraction and negative 9 do make a positive. So I can actually write in the plus, that change. So negative y plus 9y, 9 minus 1 is 8y. And negative 1 plus 9, 9 minus 1, 8y. 4z minus 15z. Well, we'll have it be negative because 15 is bigger. Negative 11z, yes. And lastly, negative 3 minus negative 21. Well, the negative negative makes a plus. Almost 18. Because we're taking 3 away from it. Yep. You're good. And if some of the negatives, especially with the numbers, are sometimes tricky or you struggle with those, use the calculator. Because with the last one, we could say -3 plus 21. We could say -3 minus -21. And the calculator will work it either way. It does not matter too much to it. If you do type some of the others in, like our -y plus 9y, do not put the variable. Because for both calculators, the TI-30XS and the TI-84 Plus, it has to have a specific value assigned to it. If you don't assign a value to it, it's just going to take whatever value was last assigned to it, which most likely is 0. So it's not going to help. Just plug the coefficients numbers in front in. Questions? Questions on this so far? So we comfortable with everything so far, yes? Because so far we've taken 3 equations with 3 variables and turned it into 2 equations with 2, yes? Now at this point here, until the very end, we start actually finding values. That eliminator equation is not going to be used again until once we actually start finding values. Does that make sense? Because we used it to eliminate x out, it's done for now. We cannot use it as part of the solving for the rest of the steps. So what we're going to look now is these 2 here. We ready for the next step? The next step in this process. Yes? Well, pick a variable and eliminate it. Essentially what we just did. But the only difference is we don't have an equation we're going to use to eliminate it from. So essentially we're doing almost exactly what we just did on the first step without an eliminator equation. Now, just like we did with x, because we looked for one that would be easy to make the 2 be the same, we do the same thing here. So looking at between y and z, the easier of the 2 would be z, correct? No. Yeah, y would be easiest for this one here, yes? Because what's the value in front of both y's? It's already the same. I don't have to do anything to either equation to get the values of y to be the same. The number is in front. If I wanted to eliminate z, it would not be an incorrect step. But for the equation on the left, I'd have to multiply it by 11. The equation on the right, I'd have to multiply by 7. I'd have to actually do something to both equations. Here, it's already 8. So what we can do is I can just take both equations and put them over the top of each other. We can go on and start. So what we're doing now is eliminating y. So we chose y to eliminate because the value or the number in front of both y's was 8. We don't have to do anything to it. So we eliminated x first. Now we're eliminating y. Okay. Questions? So, will we need to add the 2 together or subtract them? So I can try subtraction first. 8 minus 8 is 0. Okay, so that means we're going to subtract all the way through. 8y minus 8y is indeed 0. 8y minus 8y is indeed 0. We'll move on to the next one. Negative 7z minus negative 11z. because our negative makes a plus.
And then it's plus -7.
Yes, 11 plus -7 gives us 4. And lastly, 26 minus 18 is 26 minus 18 would indeed be 8. So, right, because we started off with 3 equations with 3 variables. We went to 2 equations with 2. Now I have 1 equation with by? Yes. Because we know how to solve this. So that tells me what? Z is equal to 4. I've said this once with this equation, is that we're going to get all the way down and then work our way backwards. So the real last step is to, as I say, solve backwards. Now, this doesn't make sense at this point, but we're just going back up the page. Because again, I didn't say this at the start, I should have, but we really don't have a way to solve for 3 variables at the same time. We got to only solve 1. Because up to this point, you've only solved the equation with 1. But, okay, so at the bottom of the page, we do have the value of Z is 4. So I'm going to write the solution up here at the top. Not 4, what am I looking at? 2. Yeah. I think, dang. I think I was still thinking about what I was dividing by. Yeah, so 8 divided by 4 is 2. Yeah. Yeah. Yep. Yeah. Yeah. So again, that's what I think I said it the first day. If something doesn't look right, say something. Because again, I can only think of so many things at the same time without things getting crossed. So Z is 2. Now, at this point, work our way backwards. Because again, we can only solve for 1 variable at a time, yes? So looking back at this, if I go back up the page, going backwards up this page, at this step here, I do have 2 equations with 2 variables, yes? Do we know the value of one of these 2? Yeah, we know the value of. So pick one of these for me. Do we want the one on the left or the one on the right?
The one on the right, left.
Doesn't matter. So I'll show you both. So if we pick the one on the left, 8y minus 7, but we know what the value of z is. The value of z is 7 times 2 equals 26.
Wait a minute. 7 times 2 is 14.
Yes. Well, now I have one equation with 1 variable again, yes?
Yep.
Solve for y. So we'd add 14 to both sides. Plus 8y is equal to 40. Last but not least, we divide by 8. You had me thinking twice there for a second. But we get 5. Yeah. It's like, wait a minute.
Alright, now we gotta go back up 1.
Yep. So, questions on this here? Yeah. Yes. Now the last thing is, guys, we have to pick one of these, really 5, but one of these 3 equations. Because we technically have 2 more, is we have these two equations here are technically ones that we can use, but I would normally pick one of the three we started with. Okay. So I'm going to do something that y'all are probably wish you could do. And now we just need to plug it into one of them. So we'll pick the middle equation, 2x minus 3 times 5 plus 5 times 2 equal negative 7. So this is the last part of going backward and solving this. 3 times 5 would give us our negative 15. 5 times 2 is 10, negative 7. Now at this point we can combine like terms. Negative 15 plus 10 is negative 5. Alright, so let's focus up here. Now we're going to get x by itself, so we'll add 5 to both sides, telling us 2x is equal to negative 2. Yes. Mm-hmm. Yes. So we start off with negative 7. Our negative 15 plus 10 would be negative 5. When we add 5 to both sides, negative 7 plus 5 is negative 2. And when we divide both sides by 2, negative 2 divided by 2 would be negative 1. Mm-hmm. So one of the biggest things I would say, especially when solving these here, is I would keep almost a section that you're solving the work on, where kind of, if you notice, for the most part, I kept it in a single column going down, and keep the scratch work where we multiplied to get the variables to be the same and stuff on the outside. Does that make sense? So that and the number of problems for this assignment are smaller for that reason in particular, because it does take a little bit of time to work these. We ready for the next one? Because we will do a few of these. Huh? Yes. So if we look at this next one here, we will start this tomorrow.